Our next speaker is Sheryl Zhang from Juniper, and it's a natural follow-on also to Wim's presentation, and she's going to talk to us about virtual routing. And Sheryl's been with Juniper for a number of years and also spent a lot of time with Cisco, and she's responsible for Juniper's business strategy, go-to-market strategies, and products and solutions in her current role. So Sheryl, it's all yours.
Thank you. Hello. All right. Hello, everybody. My name is Sheryl Zhang, and I am a business development manager at Juniper Networks. Today, I'm going to talk about the use case for the virtual carrier-grade routing system. To me, this topic to the industry is probably like the first-time parent feel about their baby. They know that, okay, I have a desire to have a family. It's wonderful to have a baby. And they are for sure that having fun to make one. Now the baby is born. They look at the baby and say, now what? I think this is how we feel about this virtualization for this carrier-grade routing platform as well. It used to be a 1,000-pound or even fully loaded 2,000-pound system. Now we want to virtualize them. It becomes a piece of software in your hand. What do we do with it? Today, I'm going to cover 3 topics. First of all, what can we expect from such a virtualized platform? Second, we're going to talk about what are the considerations we can apply in terms of the use case discussion. The third, I'm going to talk about following the thinking process, what are the use cases that we can actually leverage or be considered for the industry. All right, to start with, I guess that as I mentioned, as a first-time parent, we know that we have a desire. We wanted to take advantage of the virtualization benefit. Okay, and then we also, in the past 2-3 days, we talked about a lot about the SDN NFV, what are the benefits? Okay, fine, this is the general direction we are taking. Now that we have this platform, what can we expect from such a platform? If you have a carrier-grade routing system, as I mentioned, it is probably in your backbone with years of the deployment actually for mission-critical services. So now that if we look at when we virtualize it, here are on the left side, it's a set of the goals that we have in mind in order to achieve. And on the right side is specific execution that we wanted to pay attention to fulfill the goal that we have in mind. To start with, we want to talk about sharing the vision of the SDN and NFV. So as a vendor, when we actually design the platform, we want to make sure that we closely follow the trend or the movement in the industry and comply with the architecture specification from the SDN and NFV. The second thing, when you have a new tool in your hand, it's a virtualized platform, but it's a product. As a product, we still expect that this product can continue to support all the traditional revenue-generating services. It means that, okay, I have years of experience developing all of the carrier-grade routing functions, IP and MPLS, all the things you can name for. We wanted to maximize the chance actually to leverage all of them and moving to virtual. And talking about performance, I think for all of the vendors, many of you are from vendors, we are talking about who has the biggest box. Per slot, maybe a 1 terabit, even 2 terabit. For an x86 architecture, we know that we are not going to achieve the same amount of the throughput, but we are trying hard to apply all of the latest technology that we can in order to achieve the highest performance that we can achieve out of this architecture. So there is a difference, because many of the vendors have tried in the past. We run into boundaries and the obstacles. We can only achieve, let's say, 1 gig or 5 gig or 10 gig performance. But today, with the effort that all the vendors put in, we have seen the growth actually from the 80 gig or 60 gig to 80 gig to all the way to more than 100 gig per instance. Beyond that, this virtual platform is not going to live in a vacuum, just to have the virtual for the network. It has to coexist with all the physical platform that you have in your network. It means that it will still apply that all of the things that we had designed, we had in mind, or the operational process we have in place to make sure that seamlessly that the virtual and physical can coexist. So the OSS, BLS, the NMS, and the EMS, it should be able to manage both virtual and the physical. You don't have to change all of the process. It also means when you introduce, you will still need to apply the interoperability that you have in the past. No matter what vendor you are talking about, interoperability is still important. And the physical and the virtual, they have to provide the same set of the services or functions. They have to be able to function actually among different elements. Beyond that, what else can we think about? So I think that in the past 2 days, we talk about a lot of benefit about SDN and NFV. But at the same time, I hope that maybe some of you or many of you get the feeling or sense as well that there will be a lot of change that down the road actually need to be applied to your network. So it means that to us as a vendor to design a platform, we want to minimize the changes that we have when we introduce a new platform, a new product to you. So you can worry about your integration about the OSS, BSS with your NFV, that is the orchestration system, but the last thing you want to do is to try to figure out, okay, the virtual now, it behaves differently than the physical. What do I do with it? We want to make sure that you got exactly the same experience of the physical with virtual. No training is required, no new function is required. You have the consistency cross with physical and virtual to simplify your operational process, to adopt the NFV and the SDN. At last, so we talk about the traditional concept about carrier grade routing. It means network stability and also high availability. The network stability, I think when we talk about virtualization, many vendors have tried, say that, okay, we're going to introduce a brand new software. But think about it. All of the vendor takes about decades of the time and working closely with the service provider, try to figure out what is the best practice to design the hardware and the software system. Design the protocols that you needed and design the service you needed. It's a carrier grade. It takes time to do so. If we ever wanted to actually create a new platform in the virtualized form, we really wish that we can leverage all of the experience that we have, make sure that we have the stable software and the mature software that you have in the past and apply it to the virtual. For high availability, now we don't have the physical box. We look at the high availability that in two forms right now. Now at the bottom level, as we all know from the NFV architecture, the NFVI actually specifies the resilience and the high availability and how it should be achieved. This is ongoing discussion. As a vendor, when we provide a virtualized platform, we want to have the consistency to make sure that we take advantage of that. At a higher level, as a VNF by itself, we want to apply the same thinking process that we have for a physical, basically have the carrier grade, the product design, software design, and the protocol design, and the practice to build a network. All right, we talked about all the theory. Now let's take a look at the commonality that we see from the industry. In the past year or so, all of the major vendors almost have announced that they virtualize the platform. We see the commonality. First of all, most of the vendors trying to actually make an effort to make the consistency of the functions and features between the physical and virtual, have carry on all of the carrier grade routing function that we have. We also wanted to make sure that it's easily integrated by the NMS or EMS system. So there's no reason to introduce anything new if we don't have to. And here that, as I mentioned, with different goal in mind, there's two sort of side of the effort. On one hand, some of the vendors putting effort to say, carrier grade, all what I wanted to achieve actually is performance. I'm just aiming for performance. Let's compete to say that who has the highest performance ever. Well, this is good, so all the vendors are doing that. But we don't want to actually come with a price, say, well, you are trying to optimizing the performance at the same time that you forget about how you design your software, or the physical function, or the routing function, how it's being designed. We want to make sure that you get the consistency. with consideration of high performance, and yet that make sure that we carry forward all those consistent in terms of software design and the software the release maturity. And at last, we talk about the performance. I think that maybe two things. Performance, we have seen that ranging from 100 meg to all the way to 100 gig. Maybe down the road, that who knows, we will see the trend actually going to past the specialized hardware with ASIC-based technology and the x86-based the server architecture. We will know that the industry will evolve. By the end of the day, we will see that what we can achieve in terms of performance later on. So now let's have the fun of the use case. I guess many of you will laugh that when you see the graph I put on it. I'm a Chinese, come on. So I use chopstick. But when I get a tool that with a fork, actually, I would not think that the fork is going to replace the chopstick or vice versa. It's two options, two different tools that we offer to the service provider. Why do I say that? Because commonly when we talk about use cases, most of the easy way or straightforward way to think about use case is to look at the network diagram and say, okay, I got ranging from the setup box or CPE all the way to the core, which one do I replace? There is a physical box, no big. Okay, I replace it with a virtual. And people are having back and forth discussion on different considerations. Well, this is very straightforward way. But to me I think I would urge the industry to give a second, to wait for a second and say, is that all what we can think about when we got a new tool in our hand? Is that all the use cases we can think about? So before we dive into the different variety of the use cases, let's take a close look at the personality of the the different options that we have in hand, the characteristic and the capabilities. So if in the last 2 days, we had a lot of discussion about virtual, the characteristic about the virtual. Well, it's very easy to understand. If you look at the white color block, so this is the common things we discussed in the past few days. We wanted to take advantage of the cloud-centric deployment to get the economy of scale, lower the TCO. We want to have the agility, quick to launch a service, click to launch. And it's also that very easy to start a new service with lower entry cost because there's no specific hardware required. And of course, that you have a new tool to scale out. All of the things has been well discussed. On top of that, we know that we also talk about the parity. It's very critical for us to look at a physical and a virtual has a function parity. And beyond that has a management system that supporting both physical and virtual as well. One thing I want to spell out is the control plane scaling. Well, if we look at the virtual platform, one of the things that it will offer a significant benefit to us is look at the control plane-centric functions. In the past, we are bound to a particular routing forwarding engine, say, okay, this is a hardware specification. All what you can achieve out of this control plane scale and performance is bound to the physical setup. Now that we get a chance to make it virtual gives us a chance to choose at what type of the CPU and memory you have, giving you a chance to choose the optimal the hardware setting that you have for you to achieve higher scalability and performance. And on top of that, most of the vendors also are making an effort. Make sure that a specific control plane the protocols actually can recognize there are multi-cores with spreading a different process on different cores or thread. So this is further giving us a chance to enhance the scalability and performance. All right, now let's have the side-by-side view about physical and virtual. This is actually a summary if we look at what's going on with the physical and virtual. We know that if we, based on the latest the data in hand, look at the Intel the development, what they claim that what the server can achieve in terms of performance. We also look at the based on ASIC-based technology, what we can achieve in terms of box, that is the throughput and performance. Well, at least in the next few years, we see still a quite big of the discrepancy actually among the throughput that each of the platform can offer. Probably is in the realm of the 20 or even more times the differences. Well, we look at the physical. Clearly, it's very good at high throughput, high density. It clearly gives you the high efficiency in terms of power consumption per throughput. Similarly, you get the highest the efficiency in terms of pricing, price per gigabit. And beyond that, we also know that ASIC-based technology, a hardware platform, gives you the SLA that you needed. It's guaranteed. It's very well designed and proven and true that the technology, giving you the consistent performance to deliver a service. These are the things that hardware is good at. And then if we look at the virtual, clearly that as we discussed, actually the most important characteristic about the virtual is agility, giving you a chance to try something new very fast, easy to launch a service. And also in terms of the price per throughput, we actually look at the virtual. It gives you a chance to pay as you grow. It's a different model than what you expect from the hardware. So it clearly, to me, if I look at the side-by-side about these two platforms, to me, it means that each of them has strengths, and they are good at different things, and they are built for different purposes. Well, all right. Knowing that each of them actually is good at different things, now we can really take a look at what can we do in terms of use cases. I put all of the use cases I can think about into 3 buckets. The first bucket is the white portion on the screen. Basically, it is traditionally that the industry has been spending time saying, okay, I have a point function, a role in the network, blah, blah, blah. So I would like to have a comparison between physical and virtual, trying to say, can I put the virtual exactly on the same spot? Well, there's no right or wrong. This is what the customer wants. They have different reasons, different purpose to ask for that. Clearly, that there are a lot of discussion actually around that already. So I wouldn't want to spend too much time actually on it. So to us, if I look at the second category and the third are the most interesting ones. You get a chance to actually be beyond the one-to-one form mapping kind of the use case. To me, that's the second category. We should be able to think where actually there's applications, a physical is not feasible or ideal at all. For example, for the Amazon, that's the cloud, or a Google Cloud. When an enterprise have the virtual private cloud, they probably have multiple, and ideally they would like to put a router there or a function, service function there to control how the routing goes or how the policy goes. But in this case, a physical is not possible. Not everybody can carry all the hardware actually to Amazon to install it there. This is clearly that virtual is showing advantage, actually making a brand new footprint in the cloud space. And the second is also very interesting. I call it multifunction integration. In the past, actually, a few months, when we started the discussion on the virtual platform, we actually hear interesting requests actually from different vendors in the different industries, and also that from customers as well. Say, okay, now I like the virtualization, that is a toolkit. Can you actually making sure that so we have x86-based service card actually into an existing box, and then putting different type of the function on top of that. So I get a chance to see multi-function integration. We have seen that actually from the mobile side, from the radio vendors, from microwave vendors. We heard it from RAD, from the read to need card. We've also heard from the energy that the company, they offer the smart grid. They're talking about similar things. Can I actually integrate a routing function actually into my box? These are the type of things that the organically actually is growing. People's imagination around wild and said, can we do that? And I think it's excellent because it opens our mind to look at all the different possibilities that we can actually use the virtual platform and take advantage of that. But truly that I would like to actually discuss the third category, which is basically talking about a traditional concept. Let's say the CE, the PE, and then talking about the service complex. We have a chance on the first category, say it is a one-to-one form kind of mapping type of the deployment. Is there any new way, brand new approach that we can think about to offer the service? So think about the PE service. The VPN is a mature services with a broad side of the broad range of the protocols to support that. But are we all satisfied with that, especially service providers? I think they still see there's a range of the business issue and technical issue to address. For example, if you look at the red color at the bottom, consider that you typically the provider offers services to a large the enterprise. Coca-Cola, for example, Boeing, for example, they got millions of dollars of services a year. Wonderful. But the problem is that the service provider is facing the competition as well. Everybody is trying to grab the most important customer. So the question comes, can I actually expand to a market segment to offer the VPN services I couldn't actually touch before? This is number one question. Second, can I actually expand the quantity, so the coverage that I want to have different class of service and also wide range of the customer space as well. This is a business requirement. But there is a technical issue that bound with it. We know that the VPN services is positioned on the physical, on the blue color box here. You will actually use your precious, the VRF resource on the box. Every time you touch it, so you are going to potentially basically impact the stability of the box actually the Coca-Cola is paying $1 million for. You add a large quantity of small customer to the same box where the Coca-Cola service is terminated. Maybe it's not a control plane, it is not a folding plane issue at all, it's a control plane stability issue. And also that when you have the large quantity, the control plane actually take a hit. Say, I have large number of the protocols, the interfaces, and services being provisioned. Can I get the ideal that the SLA that the Coca-Cola is paying for? These are the technical issues that we hear. So now that what we wanted to look at, on the right-hand side, can you imagine that it's a college, actually community college? They want only 10 meg, 5 meg, or 20 meg access services. What can we do with it? To me, that the green box actually on top is the virtual platform that we deploy in a data center, in a distributed or centralized way, or a cloud environment. We get a chance, there's no need to invent any new protocols. We already have all the toolkit actually to channel, we can actually channel all the small enterprise customer back to the cloud environment. Why do we do that? First of all, if we look at from the top, the service actually is the virtual and the physical have exactly the feature parity and offer the same type of functions. And they can offer the service, but with different type of the SLAs and requirements that are being hit. And the second, that the precious resource on the physical box, let's say every vendor has a limit on the VRF. Now you don't have to concern about the blue box, say, I hit a limit of VRF. Now you can expand in a virtual layer in the cloud. You can have as many of the VRF as you wanted, unlimited. You also get a chance, say, you channel it all the way back to pseudowire, channel it back to the cloud. You don't touch anything, the physical box where you terminate the important premium customer. There's network stability can be guaranteed. There's no need to do that. And by doing all of this, you can also offer different type of service for different reasons. If the customer has a requirement, say I have a special requirement for VPN, you can feel free to choose a specific software release and run it on the virtual. It has nothing to do with your physical. And with all of this, you're solving your technical issue you have in hand. And look at the even bigger picture. Look at SDN and NFV, what we wanted to achieve. Down the road, I just put a box there, say it's a service orchestration controllers. It can be a set. We can define a set of the services. It's VPN, but with different profile requirements. And the controller should be able to have the intelligence, say, with the set of the requirements, it translates it to parameters. And I think the service placement is best to be terminated on the physical at maybe Atlanta or maybe San Francisco, or it should be terminated in a virtual environment, actually in the cloud. It's possible. Why not? So to close this particular slide, the previous one, is all of the benefit I just talked about, just as your reference. To close it, to me, we can learn about 4 different things from the discussion we had. The physical and the virtual You don't have to choose. You can have both actually in the same network. They can be seamlessly blended to provide the same services, but from different purpose. The second, in order to get the best of the two worlds, we better actually make sure that we use them wisely based on the strengths of each of the platform. And the next thing is we consider the NFV and the SDN. The service-defined definition should be at a higher level, and the virtual and physical at the forwarding level should be able to actually support the infrastructure or the vision that we have to dynamically initiate a service at any point that we wish to be. And to close it at the last, the virtual platform, I would like to say it's a new tool that's being offered to your service provider. We should be able to think differently and build the network differently to address either a technical or a physical business issue. There are many different use cases. I put it in the slide deck that in case that you can download and take a look at what are the other things that we can think about. One thing that I actually do want to mention is one of the very well recognized use case is about the lab, actually the proof of concept lab, software release validation, or you do operational, the network planning and troubleshooting. All of this, if we get a chance, say, the physical and virtual has a mirroring effect. It has the consistency that we wanted. The number one use case is actually is easy use case is put into the lab. So you don't have to buy the hardware anymore. You can actually easily scale your lab environment and get the consistent behavior. Consistent meaning not only from feature, but also from troubleshooting from the behavior-wise. It's number one thing that actually we can see that benefits the customer immediately. All right. To me, that the use case, the limitation is our imagination. So we have many different use cases actually we can list it here and maybe in this forum that many vendors have shared. I want to close this presentation to come back to my original question at the beginning. To me, that for the vendor and as an industry, when we look at a carrier-grade virtual routing system, what do we expect? We expect the carrier-grade routing functions, IP, MPLS, all of the whole 9 yards we expect from a physical, we want it on the virtual. And the second, we wanted to achieve the performance possible based on the x86-based server. We also want the consistency to ease the operational the process. There's no new training that's required. And beyond that, we wanted to make sure that it's a mature software that we had before developing for the last 10 to 20 years, and we've applied it to the virtual. And in terms of the use cases, to close it, to me, that physical and virtual, you don't really have to choose. You can really make the best usage of both by making sure that we understand the personality, basically the strengths of each of the options that we have in hand. And at last, I still would like to urge the industry to be open-minded. Now you got a new tool in your hand. We have a chance to address a technical issue and a business issue differently. We can think differently, we can build differently, and we can actually achieve a lot more innovation down the road. All right, that's my presentation. Thank you. Thank you.
We'll hold questions because we're running a little short on time, but I think Sheryl will be here for a while, and also the Juniper booth outside, the people will be glad to give you some additional details. So, thank you.